as most of you know, every day we'll try to pick a question from lead code, an interesting question from lead code, and try to solve all the possible follow-ups of that particular question. Currently, in this video, we will be looking at one of the questions from Microsoft SD2 interview experiences, which was posted around 2 days ago. And in this particular video, we'll be looking at the first particular question. And in the next video, we'll be looking at the second question of this interview experience. So let's start. The first question states that there are two strings A and B, each of same length, and we have to count the number of fragments of A and B which are good. So what is a fragment? The fragment is defined by the substring of A and the same substring of B. So basically, if we take this substring of A, B and A, we have to take only this substring of B, and if the frequency of every character in both of them are equal, we will say that it is a good fragment. So in this case, first string contains small a one time and capital B one time. So we will say that this is a good fragment, and we will add one to the answer. Now, for example, if we consider this fragment, here small a appears one time, small a appears two times in the second string. So this is not a good fragment. So we will not add anything for this. So the problem is we have to count all the possible fragments. Now, as we do in every video, before jumping to the solution itself, let's try to think of if there is any ambiguity in the question or not. So I will encourage you to pause the video and think for a minute if you can think of any ambiguity in the question. So let's discuss the ambiguity. So there is one important ambiguity in the question. The question doesn't clarify what are the possible characters in the given strings are. So we will see the solution can change based on what are the possible characters in the given strings A and B. So for the purpose of this question, let's assume that string will contain only lowercase and uppercase English alphabets. So the solution will not actually change. Uh, the solution will not differ a lot if other characters are allowed. Let's say dollar and question mark and all those things. But this is something that we should clarify first. Now, what is the brute force approach to solve the question? So we have to count the number of good fragments, and a fragment is substring. So why not consider every substring of the given strings and see if they are good or not? So how to calculate whether they are good or not? Just calculate the frequency of every character of the string and see if the frequencies are matching. So for example, this is what we will do. So we will we will iterate over the first index of the substring, and then we will take two maps. The first map will contain the frequency of every character in the first string, which is A, and the second map will contain the frequency of every character in the second string, which is B. Now we will iterate over the ending character of the substring, which will start from basically I and go till n minus 1, and increment the particular character in both the frequencies array. Now at the end we will check whether the frequencies are equal. If the array is equal or the map is equal, we will say increment the answer, otherwise don't increment the answer. So what is the time complexity of the approach? The first loop will be iterated over n times. Second loop will again be iterated over n time in the worst case. And inside this, we are calculating this, checking this f1 equals to f2, which is a map of C characters if there are C distinct characters. So total complexity of this solution is n square C. Okay. So whenever you see a problem where you are actually trying to compare the frequencies of two array, you can actually optimize it and remove this factor of C altogether from the complexity. How? Let's look at it. So let's assume the same scenario. We are given these two strings, and we are maintaining this f1 and f2 as in previous case. Along with f1 and f2, let's say we are also maintaining this equal variable, which will denote how many elements are equal currently. So initially everything is 0 here, everything is 0 here, so all the 5 elements are equal. Now let's say we start our I from here, and the second variable j is pointing at here. Okay, so what we will do, uh, or second variable j is pointing also at this. So now what we will do is we will increment the frequency as we go along, as we are doing in previous solution. So we found d, we will increment this the frequency of d by 1. Now as we increment the frequency of d by 1, we will see that okay, these two now becomes unequal, so we will decrement this equal to 4. Similarly for this we found c, so let's increment the frequency of c by 1. Now as we increment the frequency of c, we can see these two are now not equal, so let's decrement this again to 3. Now we will move forward to b here, and we'll move forward to a here. So frequency of like now we'll increment the frequency of capital B, so capital B now becomes 1. Now as capital B becomes 1, we can see the frequency are again not equal, so let's decrement this again. And in the second part we will increment capital A, small a, so let's increment this small a by 1. Again this will lead to this two becomes unequal, so let's decrement this again uh, to 1. So okay, sorry, initially there are 6 characters, so this equal was 6 actually. So 5, this will be 5, this will be 4, this will be 3, and this will be 2. Okay, so there are two strings which are equal. Now after this, let's say we go one more character above. So here we got a in the first string, so we will increment this to 1. Now as soon as we increment this to 1, we will see that these two again become equal, so these two will again become 3. Okay, now we will increment the capital B here. So as we see capital B incremented here, these two again become equal, so we will increment this 3 to 4. So hope you get the intuition of what we are doing. We are basically maintaining this equal variable which will tell us how many elements in this two arrays are equal. So we will only increment the answer when the equal variable is equals to total distinct characters, which in this case is 6, a b c d capital A capital B. So if equal variable is 6 for any subarray, we will say that that's the answer. So previously we are iterating over every subarray, and then we are comparing the uh, frequencies array. So that was requiring order C time. But now instead of comparing the frequencies array, we will just see whether the value of equal variable is equals to 6 or not. So this C is not required. This will be directly be one order one operation, just comparing the value of very equal variable with 6. So that's how we reduce this C from the time complexity. I will encourage you to pause the video and try to implement this solution on your own. Next, we will be looking at a sample implementation of this solution. So this is the sample implementation. This is the count of equal fragments function. So basically, I am finding the length. So the problem states that the length of both the strings are equal, but in the case they are not, we will do minimum. So after that, we are taking the frequency array f1 and f2 in our case, and we are also maintaining another count. So in original question, the count was not 6, it was 52, like capital A to capital Z and small a to small z. So total 52 characters are there. So hence initially every 52 characters are equal, so same frequency count is 52. Now we will iterate over the second character, like the ending character of the substring, and we got, let's say, C1 in the first string and C2 in the second string. Now we will check whether the frequency of C1 is equal or not. If it is equal, it means that we are actually trying to, we will increment the frequency in next step, right? So if they are already equal, they will not remain equal after this incrementation step. So that's where we are decrementing the frequency. Similarly, if frequency, after incrementing the frequency, they become equal, it means they were not equal before, but now they become equal after incrementing it. So we are then incrementing again the same count frequency. Similarly for C2, we are checking whether they are equal before or not, because if they are already equal, after incrementing it, they will not remain equal. So that's where we are decrementing it already to by 1. And after incrementing, we are again checking whether they are now equal or not. If they are now equal, it means they are not equal before incrementation, and hence we got one more equal value in the two arrays. Now at the end, we will just check whether the value of this variable same count frequency is 52 or not. If it is 52, we will increment the answer. So if anything is unclear, I will recommend to watch the last 5 minutes of the video. You will definitely understand it. Now we have like our complexity of our current solution is order n square, but we can do much better than this. So whenever you see a problem including substring or subarray or something like that, you should at least try once thinking about the prefix sum or prefix array approach. Okay, so let's try to think of that approach in this case as well. So let's say for simplicity, let's say the string contains only a's, okay, and underscores. So basically this is the first string a, and this is second string b. Okay, now we will calculate the prefix sum array as we do every time. So we calculate this prefix array 1 1 2 2 and 2. Basically this 2 denotes that there are two a's before this position. Now let's calculate the prefix array for this as well. So this 3 denotes that there are 3 a's before this position. So let's denote this prefix array of first string by small p, and let's denote the prefix array of second string by capital P. Now when we will say that, let's say like we have to find the same thing. We have to find whether a segment here, a fragment here is equals to a fragment here or not. So how we will say that? So a fragment is equal only when the frequency of a in both the cases are equal, right? So a fragment is equal when, let's say we are considering a fragment this which is ending at I and starting at j plus 1. Okay, so if we are considering this fragment, then we what are the number of, like we have to find out whether the number of a's in this fragment is equals to number of a's in the corresponding fragment of the second string. So how to find the number of a's in the first fragment, in the first string of the of fragment ij, is this pi minus pj, right? Like this is the number of a's in the first string of I comma j fragment. Similarly, the number of a's in the second string is capital pi minus capital pj. Now let's just rearrange this a little bit. Let's move this here and let's move that here. So or move this here. So after doing this, we will get something like this: pi minus capital Pi equals to Pj minus capital Pj. So what does it mean? It means that if we just subtract the ith index of these two, and if they are equal, it means that the fragment I and j is actually a valid fragment. So let's do that. So let's subtract the ith element of these two p, this p and this p. So let's do this for every element. So the first index will be 0, 0 minus 0. Second index 0 minus 1, which is minus 1. Third index 1 minus 1, which is 0. Fourth index 1 minus 1, which is again 0. Fifth index 2 minus 2, which is again 0. Sixth index 2 minus 3, which is minus 1. And seventh index is 2 minus 3, which is again minus 1. Okay, so this is the uh, pi minus capital Pi array. Now, according to this equation, if for any two index they are equal, it means the corresponding fragments are equal. So when we can see that this position and this position are equal, it means this fragment is actually equal. So we can just verify this here as well. So this fragment contains 1a and corresponding fragments also contains 1a, right? So similarly, for this 0, let's try for this 0. For this 0, this is 1 0, this is 1 0. Basically it means that this fragment and this fragment are equal. So we can just verify this as well. So the first fragment, which is this fragment, actually denotes the this fragment of this, and here it denotes the, sorry, third and fourth, right? So basically it denotes this, only this fragment, because the prefix sum is actually j plus 1, right? So and here it denotes this fragment, so this we can see that they are equal. Similarly, the complete fragment here, like basically this fragment and this fragment, we can see they are also equal, right? Now let's try one more example here. So let's try for this one this time. So here this is equals to this and this. So what it means that this fragment and this fragment are equal. Okay, so this fragment is this, we can see they are equal. Similarly, this fragment denotes this one, we can see they are equal, correct? So that's how what we are doing. Basically we are trying to calculate pi minus pj, and for every index we are just trying to find how many uh, same elements are there before me. So for 0 we will try to find how many zeros are there before me, and we will just add that number to our answer. So hope the approach is clear. So we are like we have simplified our, like, if you remember our like, actual question contains more than one elements, more than one characters, but we have simplified this to a single character a. But and we see that this, if this equation holds, it means we are like we got the number of fragments, good fragments. So if this equation holds for all the characters, let's make it ak. So if this equation holds for all the characters, small a to small z and capital A to capital Z, then also we will say that the same thing is true. Like frequency of all the characters are equal in this particular ij fragment. Hence, this ij fragment is equal. So let's just look at the example to make it more clear. So let's assume that this is the this is a string, and again let's assume that currently there are only six characters: a b, capital A, capital small a, small b, small c, small d, capital A, capital B. In our original question it says that we have 52 characters, small a to small z, capital A to capital Z, but for this question we are assuming that there are only six characters: small a, small b, small c, small d, and capital A, capital B. Now, as with the previous approach, we will calculate the prefix sum of each of these characters. So we will calculate the prefix sums of small a, prefix sum of small b, small c, small d, small a, small b, capital A, capital B. So how we will do that? We will just if d occurs here, we will increment the frequency of d. So first character is d, so we will just increment the frequency of d, and rest of them are 0. Now second character is B, so we just increment the frequency of capital B, and rest of them are same. So notice that D is 1 only because we are calculating prefix sums. Okay, so again the third character is A, so we will increment this to 1, and notice that these two are again 1 because of prefix sum property. So for C we will just increment the C. For A we will increment this A, and rest of them are same, and for this capital A we will increment this capital A, and rest of them are same. So we will do the same thing for string B as well. So string B contains C A B D A. So C A B D A, and these are the six characters that we are saying that is there with us. So we will calculate the prefix sum again like the same manner. Now what we have is basically this is the P array, okay, and this is capital P array. So if you remember, we have to calculate the difference between P and P, right? So let's do that. So first, for the first row, everything is 0 here, everything is 0 here, so everything will be 0 again. Okay. Now for second row, this is 0 minus 0, 0, 0 minus 0, 0, 0 minus 1 is minus 1. So that's where minus 1. 1 minus 0, which is 1. So that's where 1. So similarly, we will do calculate for all the rows. So let's just look at the last example. So 2 minus 2 is 0. So that's where 0 comes. 0 minus 0 is 0. So 0 comes. 1 minus 1 is 0. So 0 comes. 1 minus 1 is 0. 0 comes. 0 minus 0 is 0. And 1 minus 1 is 0. So hope this is clear. So this is basically the array P minus P. Okay. Now once we have this, if you remember what was the what we have to find, we have to just find how many, like for each index I, how many how many indexes are there before I which are equal. Okay, so let's just assume that this is our I. Okay, so for this I, we have to find how many of them are, how many indexes are there which are exactly equals to this vector. So currently there is one only which is exactly equals to this vector. So hence this particular uh, this particular fragment is equal. So this fragment is for 0 1 2 3. So we can see 0 1 2 3 and 0 1 2 3, this is exactly equal. So we can just manually verify C occurs once, small a occurs once, capital B occurs once, and small d occurs once. So now just let's just take one more example. So let's take this one now. This is our I. So if this is the I, we will try to find how many of them are equals to I. So in our case, it will come that this and this are exactly equal. So we will just add 2 to the answer, and we can again verify that this is exactly equal. So 0, 1, 2, 3, 4. So fourth one here and fourth one here are equal. Okay, so because this is the particular segment which basically means this one only, j plus 1 to I. Now second is this particular part. So this particular part is from 0 to 4. So you can see from 0 to 4 and from 0 to 4 they should be equal. So there are two a small a's, there are two small a's, one small c, one capital B, and one small d. So hope you got the answer. Hope you got the idea. Basically, we are calculating this P minus P array, and for each index I, we are finding how many indexes are there before me which have exact same vector. So let's look at the code for this as well quickly. So we have again the same function count of equal fragments. Now again, this time we take a map of vector of int comma int. So basically we want to find how many integers or how many indexes are there for which this exact vector is equal, right? So this part, so how many indices are there for which this exact vector, this entire part is equal. So that's where we took the map of this vector to its frequency, like how many times this vector occurs. So now initially we put everything is 0 in f1 and f2, so we just take the difference. So difference is nothing, we will difference is nothing but taking two arrays and calculating the difference between them and returning it. So we will just return the difference of the two arrays. Initially we will find the difference and that will be 1. So basically everything will be 0 and the frequency of 0 is 1. Now we will iterate over every index one by one. For each index, we will increment the frequency in f1, we will increment the frequency in f2, and then we will find the difference vector. Once we find the difference vector, we will just increment answer by current frequency, like how many times this frequency stores actually how many times this vector appears, right? So how many times this vector appears, we will just increment this our answer by this, and then we will increment that frequency itself. Like basically this vector now appears one more time. So for just to clarify, if at this point this 0 0 0 0 0 0 occurs uh, two times, So we will add this 2 to our answer. After adding this 2, we will make it 3 because now it occurs 3 times. Okay, so that's what we are doing. We are incrementing our answer by this, and then we are incrementing this variable itself. After that, we are just returning the answer. So hope you got the, so like what's the final time complexity? The final time complexity is order n into c. Basically, we are, this is the first loop, and in this loop we are just calculating the difference array, right? And assuming that this map can be map is constant type, like we can also use unordered map here as well. So that's where like I'm just assuming that this map is constant, taking constant time. So we are just calculating the difference array here, and this difference array will require order c time, like number of distinct elements that we have. So that's where the time complexity is now order n into c. So just to show out the journey, we started off with n square c, and then we show that every time there is a c here, we can almost every time reduce this c by introducing a count variable. So that's where we remove this c, and now we are saying that because it is like sub array problem or substring problem, so let's try the prefix sum approach. And by trying the prefix sum approach, we got a nice equation in terms of I and j, and from there we kind of calculated this logic and reduced this n square to n into c. So hope you enjoyed the solution. If you like the video, please like the video and subscribe to the channel. I am posting this kind of videos regularly, so make sure you hit the bell icon to get it notified. I will see you tomorrow. Thank you.